This is Codeforces Round 899 due to, and we're gonna solve the second problem, that is sets and union. Let's quickly understand what the problem states. So everyone know what is a set, right? A set is a data structure that contains only unique number of elements. In math also it's same, I believe. So you have n sets of integers, s1, s2 up till sn. And when do we call a set as attainable is it possible to choose some of the sets in s1, s2, till sn so that s is equal to their union? Okay, so if you choose none of them, the union is an empty set. Our goal is we need to find the maximum number of elements in an attainable s such that s is not equal to all of these numbers. So let's say that s1 is 1, s2 is 2 3 4, and s3 is 2 3 4. If we take the union of all of this, what is the value of s? S will be 2 should not occur 2 times, 3 should not occur 2 times, it is just 1 2 3 4 if we take the union of all of these numbers. Now what is the maximum number of elements in an s such that s is not equal to s1 till sn? So is it possible for me to take s2 and s3 alone? If I take if I take s1 and s2 alone, what is the union? S1 union s2 is equal to what? 1 2 3 4, right? So this 1 2 3 4 and s1 union s2 union s3 is also 1 2 3 4, and both of them are equal to s. So they are clearly telling that s should not be equal to this value. So s1 s2 is invalid and s1 s2 s3 is invalid. What is the maximum number of elements possible? Now if can I take s1? Okay, 1, this is also valid. Or s2, it takes 2 3 4, this is also valid. Or s3 alone, this is also 2 3 4. Or s2 union s3, that is 2 3 4 only. So what is the maximum number of elements we got out of all of this? That is 3 elements, right? This one is only 1 element, this is 3 elements. So if this condition should not be satisfied, we have only s2 union s3 or s2 or s3. So 3 elements are possible here. So I hope the thing is clear. So only thing is, if you combine all of this, you should find a set of numbers. You should combine certain sets from s1 till sn such that it should not be the union of all of this. That's all. So as I told earlier, s1 and s2 is not invalid because s1 s2 s3 is same as s1 and s2. Now let's understand this with the help of an example. Let's see this 1 2 3 4 5 3 4. So 1 2 3, what is the total value? 1 2 3 4 5. What did they do? S1 and s3 they combined. S1 and s3 they combined. So this 5 won't come, right? So 1 2 3 4 is the maximum value that is possible. So 4. Or you can take that instead of this. What you can do, instead of this I can also take 1 2 3 4 5 also I can take 1 3 4 5. But in this case what happens, this is the combination of all of this, this is also not possible. So that's why they gave this number, that is 1 2 3 3 4. 4 5 3 4 is also possible? No, because 4 5 3 4 is 4 5 3 is the set, that is only having 3 elements, so it is not possible. So these are the two things. And what is this one? 1 2 3 4, if I combine all of this, what all numbers come? 1 2 3 4 5 6. What all elements can be picked? 2 3 4. So 2 3 4, if you pick it, it is 2 5 6 3 and 4. So 1 is missed here, 1 is coming only here, so I cancelled it. So only these numbers are the maximum possible. So if 6 numbers are maximum possible, 5 numbers for union of all of the numbers, 5 numbers are the maximum possible. Now this is very interesting. Let's see. So in the third case, they are telling that either take s2 union s5 or s2 union s3 union s5. So what are the total numbers? You have 1 3 6 9 5 8 10, right? 1 2 3 4 5 6, and these are 7. Now if I want to cancel one, I can cancel this one and this one. So if I remove this and if I remove this only remain, right? 3 6 9 5 8 10. That is what is happening here. 2 3 and 5, or else 2 and 5. You include 2 or include 5. Since 9 is already here, 3 6 10 5 8 9, this is already there. So you can try for all of this. They are telling this is only one number is removed all of here. But what about the last number, 428? So for s is equal to s1 here. So if I want to make s is not equal to s1, that is not possible. So you have to print 0. 0 is an empty set. So 0 is the maximum number of elements. How do we do it? So what all things did we try here? We tried that, okay, it can be number wise also or it can be set wise also, right? Here what did we say? only one set has been removed. So let's say here in this case S1 union S3, okay, can I remove S2 alone and combine S1 and S3? Can I remove S1 alone, combine S2 S3? Can I remove S3 alone, combine S1 S2? That can be one possibility from the test case. Then what are the other things? Here what did we do? If I remove this number alone, if I combine all of this, all the numbers will come, right? Here if I remove one also, this one is here, so this is not possible. So instead of removal of one, I need to remove two numbers, two sets. If I remove two sets, these two numbers can be removed, and if I remove two sets means these two should be removed. But it can happen that there might be cases that 3 sets need to be removed, 4 sets need to be removed, and that 4 sets might not be consecutive or something, or adjacent or something, it can be anywhere. So how many possibilities are there? 1 plus 1 and 1, 2 numbers, 3 numbers, 4 numbers, all the things. So there are approximately 2 parent subsets are there. So ultimately that is not going to work. 2 parent combinations are there, I mean, so that is not going to work. So now we have to think something differently. What do we do? Let's see the constraints. So in the constraints we understand that the n can go till 50. There are 50 rows. 2 power 50 is not possible. 2 power 50 combinations. But here they are telling that k value is what? This value. The first number represents how many numbers are there in the set. This can be 50 numbers, fine. And each of the value will be from 1 to 50 only. So it can go only till 1 to 50. So I very well know that I cannot remove one set. I have to remove multiple set, and multiple set can have multiple combinations, so that is not possible. So instead of that, we'll think in this way. Okay, the constraints are very less. So what if we try to iterate it through all the elements? That means I know that a set contains only certain number of values, right? So let's say for this example, what did we notice? 1, 3, 6, 1, 3, 6, 10, 9, and 5 and 8. So there are 7 elements. Here 1 is only missing. 2, 3, 4, 5, 6, 1 is only missing. Here also only one number is missing, right? 5 is missing. So I am telling that, is it possible for me to remove one and preserve all of this? So that is my question. How many number of elements will be possible? If I remove one, is it possible to remove all of this? Or instead of 1, is it possible to remove 3 and get all of these numbers? And is it possible to remove 6 and get all of these numbers? So that's the catch here. Now let's understand this in this way. So if I want to remove one, what will I do? I want to know what are the places one is part of, what are all the sets that are part of. So imagine if this is a 2D matrix, 1 is part of what indexes? 0, 1, 2, 3, 4, right? 1 is part of 0th index and 3rd index. 0th index, so if this is this 0th index and 3rd index. If I want to completely remove one, I need to completely remove this set and this set, right? Does I make sense? I just need to completely remove and take the union of all of this. This one and this one I need to completely remove. So if I try to remove this, what happens? So 1 already the count of 1 is there, not here, it's not there. So 1 can be safely removed. But what about 3? 3 is getting removed here, but 3 is part of this also. So I should not remove 3. If I cancel this set, 3 can be removed. So how do I know whether a number should be included or excluded from the array is? You just keep track of the count also. So for 1 is occurring how many times? It is occurring, count of 1 is 2. Count of 3 is how many times? It is 2 times. Count of 6 is how many times? It is only 1 time. 10 is also 1 time. 9 occurs 2 times, and 5 occurs 1 time, and 8 occurs 1 time. If I want to remove one, I go to the corresponding index 0 and 3 and try to remove the 1. So 2 becomes 0. If the count is 0, I assume that it is not part of any set. But in this case, since we took the second index, since we took the third index, 3 is also part of the set. So I need to decrement 3 by 1. Count should be 1. But since count is part of 1, if we combine all of this, then we assume that the value of 3 always exists in the array. So we can't do anything. Similarly, if we are taking, if the count is 2, right? This is also 2. If we try to remove 3, what are all the index of 3? We say that it is 1 and it is 3. If we remove 1, what happens? 3, 6, 10 needs to be removed. So the count becomes 1, 6 count becomes 0, tens count also becomes 0. Whenever the count is 0, I assume that it is not available in the array. This is not there and this is also not there. Now I should also remove this one. So one's count becomes 1 and this count becomes 0. If this is 0, this is also reduced. Now what happened? I tried to remove only 3, but only 1, 9, 5, 8 is remaining. I assumed that I tried to remove only 3, but only 4 elements are remaining. But I did the same for 1, but there are around 6 elements are remaining. Here only 4 elements are remaining. So who is the maximum? I take that this is the maximum. Similarly, you try for all the elements. It might happen that not only that element will be removed, the corresponding element who are part of the set will also be removed in that case. So we are taking the set here. Now, how did we come to the conclusion? Again, first thing is we have to make sure that, as I told earlier, it should not be the same set, right? S2 and S3 you cannot take in a set format. If you take in a set format, it is going to be very hard. Lot of combinations can come. So instead of that, we are taking numbers like from 1 to the maximum number. These are, you just put everything in a set and take the count and take the position at the starting itself and put everything in the set and iterate through each of the element. Now we know the index of it. If we want to make sure from S1 to Sn that number should not come, means wherever that number is part of the set, we need to remove it. In order to remove it, we cannot individually remove that number. We need to consider the entire set and remove that. If we consider an entire set, it will be removed, but it might happen that some other numbers will be part of the set that are also forced to be removed. How do we know it is removed or not? Is you keep track of the count of all the numbers, then you try to remove it. So no worries. So that's all about it. Let's try to understand this with the help of a code. So this is the code that we do, and we'll take the same example and try to run it. Now what did we do here? First thing is, I want to store this in a 2D matrix. So this is a 2D matrix, okay? So that's what this v dot pushback, the vector v stores. Temp represents each row I am taking, k represents this number, and temp represents each row I am taking it here. So temp dot pushback of everything. Once I get everything, the entire row has been pushed to a vector called as v, entire thing. Now what is ma of b plus plus is, I want to know the count of these numbers. Here we took the count, right? How many numbers are there? So I am taking the count of this. Let's write this down. 1 3 6 9 5 8 10. So 7 numbers are there. 1's count is occurring 2 times, so that is ma, and 3's count is occurring 2 times, 6 count is occurring 1 time, 9's count is occurring 2 times, 5's count is occurring 1 time, 10's count is 1 time, and 8's count is how much? 1 time. SC dot insert of b means I just want to store these unique elements. What are all the unique elements here? SC is just the set. So this is SC. Int of b dot pushback is, it takes care of the index. So int of 1 is what? Just for this example alone, I am taking index of 1 is what? This 0, 1, 2, 3. Similarly for 3, what all numbers can come? 1, 2, 3, right? So I am taking care of index also. This is also a 2D matrix kind of thing. Now I am iterating through the set. I am iterating through all the unique numbers, and I'm telling that I need to take a copy of it because I can do any operation, right? So I just take a copy of these numbers. So how do I take it? You just copy these numbers in a set. So that is, this is what? This is T set. I'm just taking a temporary set, that is copying. Now let me take the m value also, copy paste. So this is what? This is a temporary map. You can take map only also, but I just took set for easier understanding. Now you iterate through the first element. You take the first element and you iterate through all the index that are present in the first element. This is the first. I already stored the index 0 and 3. What is my next step? I need to go to my map and tell that the count of all of this should be reduced. That is, I go to this index, then go here and try to remove it. Remove it means what? I know already number 1 is here. I need to remove this, means I need to reduce the count of the map, that is 1 comes here, and any other number, nothing is there. Now you go to the third index. Third index, I'm trying to remove 1. So go to the first number, that is goes to the index and iterates through all the numbers. So go to the first number, that is 1. The map becomes 0. If it becomes 0, I am erasing from the set. Okay, this gets erased. Now it is 3. Next number is 3. You go to 3 and reduce the count to 1. Now what is the set size? Set size is 1, 2, 3, 4, 5, 6. all these numbers are same. Now again it goes, but t set takes a new copy. I took the copy first, right? Similarly it takes a new copy again. T map also takes the new copy, and once we get the copy, we iterate through the first number. First 3 6 10. 3 6 10's count value reduces. So 3 6 10's count value reduces. Whoever count is going to 0, I am reducing that from the t set. And similarly we go for the third index, 1 and 3. 1 and 3's count is reduced. If any of the numbers count is reduced to 0, we are just removing again from the set. Here we saw for 3 what did we get? We got only 1958. So the set size is only 4. So we are keeping track of the maximum element. Earlier we already got 6 here, so maximum will always be 6 here. Even if you take all other numbers, you will get it. So what happened, we just instead of going through set combinations, we just told that I should not get the total number of elements S1 to Sn union. I should not get. I just want, is it possible for me to remove at least one element and get those numbers? If I want to remove one element, the best possibility is I should go to the set, and wherever that number is there, the corresponding set needs to be completely removed. If it needs to be completely removed, there might be some of one's friends or some of their friends will be there. So those numbers also I need to erase it. So when will that number be erased is if the count of the number will be 0. That is, if the count doesn't, if we are totally cancelling that number. Suppose if we say that 5 8 9 has been reduced, 5 will be removed, 8 will be removed, but 9 is not removed because 9 is already part of this. So that's why we are taking the count. At last you take the set size. Once you get the set size, take the maximum. How much is the maximum? We just have to print that. If it is not possible, maximum will be 0 only. So now this is the submission link. So that's all. Please let me know in the comments what you feel about the video, and if you have any doubt, share it in the comments. We'll try to help. Thank you.